Hey everyone, this is Josh here for Deuces Cracked, and this is the season premiere of Applied Math. And the purpose of this video will be partially to describe my goals for the series, to ask you viewers for some help in telling me what exactly you'd like to see, and you'll get a better understanding of exactly what I'm looking for as we go through this video. And then we'll start off with our Applied Math. And it kind of dawned on me that the name Applied Math is a little bit intimidating. It sounds kind of advanced, but the purpose for this series is to take all of you from having very little understanding of math to those of you with a strong foundation of poker math, and kind of teaching you my methods for running poker math and getting you from the point where you're at right now, regardless of what that point may be, to a further point of understanding poker math. So while it sounds complex, I'm going to be going step by step and not making it so complex, hopefully, or not seem so complex. So my goal is clearly for us to just get better at poker. It's not knowing the numbers for the sake of knowing the numbers, because that doesn't do us any good. And I've gotten better at poker through understanding the numbers, and I want to lead you on that same path. And I say all games and structures because, especially for the first few episodes of this series, the examples will apply to all games and structures. I mean, this video we're not even going to be looking at a no limit hold'em example. So while I have I'll in the future, maybe episodes 4 through 8 will probably be more no limit hold'em examples. I still think the majority of this series will be able to apply to any game and any structure, from pot limit to no limit to limit. So expanding on that a little bit further, I want you to understand the fundamentals through the numbers, and I'll provide some examples of what I mean by that throughout this video. And I'm going to really kind of keep harping on that point. I just want you to get better at poker through the numbers, through understanding the fundamentals, because a lot of this series, or at least what I've planned for this series, will be testing fundamentals and showing kind of the inner workings of a lot of these different fundamental scenarios. So the beauty of fundamentals, or the beauty of testing on fundamentals, is they apply to so many different examples of hands. We're not just looking at this very one specific example. We're looking at a concept, and understanding that concept, understanding how that works, will let you apply it to a number of different, potentially vastly different examples of poker hands, even in different games. So if you're watching this series, you clearly understand that the math behind poker is important, and there are a lot of very accomplished poker players who don't understand the math, but I think those people just have a certain innate ability to just understand and improve from within. And I don't think that applies to most of us. I know it doesn't apply to myself, which is why I haven't run so much poker math in my life, because that's what sharpens my senses. I don't have that innate ability to just play hands and just see what works, see what doesn't work, and just improve like that. So I think this does apply to most people, and even if you do have that innate sense, then I still think understanding the math can only help. So as I said before, this series will be for those of you who understand the basics, for those of you who don't understand the basics. And by the basics, I basically mean using PokerStove or some other simulation program to test out ranges and equities. Understanding what is expected value, what does plus EV really mean, how to make an EV table, and then Bayes and combinatorics, and by that I mean essentially constructing a range based on combinations and weights and things like that. So whether you know these or whether you don't, I will go over them, and even if you do know them, hopefully you'll have a better understanding by the time we're through with this series. So I mean, I think the real trouble is, you watched, you read a book on poker. I mean, Theory of Poker. Theory of Poker is a very good book. The Mathematics of Poker is a very good book. Mathematics of No Limit Hold'em by Wilt on Tilt, an excellent series on Deuces Cracked. So maybe you've read one of those books or watched that series. The problem is where to start, where to basically where to start. So that's going to be the point of today's video to get us from this starting point of maybe not even knowing what an EV table is or how to calculate EV to being able to apply it to some relatively simple situations. So I figured I would give an example of how math has sharpened my senses, and you don't have to follow this completely, but I figured I would sort of explain it anyway. So last year I created a series called Playbook with another DC coach, Sounded Simple, and basically I didn't even mean for this to happen, but just running a certain or analyzing a certain hand history really gave me a better understanding of reverse implied odds and actually corrected a fundamental misunderstanding that I had about poker. So we'll take an example, a pretty simple example, not the best example, but a pretty simple one. You raise pocket nines from whatever position. The small blind makes a pot size 3 bet. You're getting 2-1 heads up. You have position. You estimate that your equity versus his range is 40%. So, you're getting 2-1. You need about 33% in a vacuum if that was, all in. And say you have 100 big blind stacks. So you estimate his equity is, you estimate your equity is 40% against his range. You also figure you have, excuse me, you have position, you have a skill advantage, and you will make good decisions post flop. So I used to think that, well, how could calling possibly be bad? We have an overlay pre-flop. We're going to make good decisions post-flop, so we'll take it one street at a time. If we keep making good decisions, then calling can't be bad. But the answer is it actually can be bad. And I'm not saying that it is in this particular situation, but the point is, even though you have this overlay pre-flop, you can give it back post-flop despite making good decisions. And reverse implied odds are the reason why. Let's say, for example, our opponent bets the flop, and we call again with 40% equity. And we, given our pot odds, that's a positive expectation call. That still can take away from this money that we've made up. And the reason for that is because we call the flop, and now all of a sudden we're putting money in on the flop as an underdog. Even though it's a positive expectation call, we're still putting money in as an underdog. And that's something I can go into throughout the rest of the series. I don't want to go into it too much, but the bottom line is we would be losing 20 cents on the dollar for our flop call. So part 2 of my goal is to provide you with the tools necessary for doing all of this yourself. And these are the tools. Poker Stove, which hopefully you have some understanding of how to use. I can do this very quickly. If you don't have it, you should download it. Basically, it's just like a simulator. Let's say you've got pocket jacks, and you think your opponent has a range of aces through tens and ace king. Your equity against that range is 43%. Again, hopefully most of you have an understanding. If you need any help, feel free to PM me or post in the video thread. But something that many of you probably don't have much of a foundation in is OpenOffice or Excel. So please, if you don't have OpenOffice or Excel, please download OpenOffice. For this series, I will be using OpenOffice because it's free. If I were to be using Excel, I think it would turn a lot of people off because you don't have Excel, or you may not have Excel. So OpenOffice is free, and we're going to be using OpenOffice for this series. And just about anything that you need to do for regarding poker math, you can do in OpenOffice. So yeah, please download this. And the whole point of this series is going to be interactive. I want you to be able to do what I'm doing. So when this series is over, you can do anything that I can do. So that's why we'll be using OpenOffice Calc as the name of the particular program, because it's free, and there's no problem for any of you to just download it. So I know a lot of people like to do this type of poker math using Word docs or pen and paper, but I'm telling you, it may seem simple. It may seem like you could possibly do it. You can write out this really long equation and then solve for X, something like that. It's just, it's tedious. It takes more time. It's less organized, and it just does not work as well. If you want to if you want to take a simple situation and start adding a lot of what if scenarios, adding multiple streets, if you're following what I'm doing throughout this series, you'll be able to do that much more easily than writing up crazy equations. Just please trust me on that. So I mean, open office, we can do tables like the EV table, as I was saying. We can figure out ranges based on Bayes' theorem, combinatorics. We can weight different ranges and categorize ranges. We can solve for variables and change those variables around. We can change variables from the weights of our opponent's range to the pot size to the bet size, things like that. And that changing around the variables is really what can give us an understanding of what works and what doesn't, and under what situation it can work. Let's solve for break-even points. For example, how much fold equity do we need to bluff in a certain situation, or how much pot equity do we need? And we'll be able to run some graphs, bar graphs, line graphs. These are all the types of things that I did throughout Professor Plotkin, and in that series, I basically ran all the numbers myself and then provided viewers with my results. The goal for this series will be to teach you how to get to that point where you can actually find your own results. So today, that where to start question is just constructing an EV table, because EV is the driving force behind poker. Just about every decision is a question of what is the highest expected value play in a given situation. So what is expected value? Expected value is the sum of the net results of all possible scenarios weighted by the chances of those scenarios happening. And that sounds complicated, but we will go into that. And why is EV important? And I said that already, because EV is what drives poker, is all decisions you should be striving to make the highest expected value decision. So I will be helping you today create an EV table in Open Office Calc. We'll start with a very simple one, a coin flip, and we will start adding layers and using different scenarios, getting a little bit closer to real poker. And the goal today is for you to follow along, and I really stress the importance of that. I mean, the whole point of this series is for you to be able to do this on your own. So if you're not following along with me today, then it's kind of pointless. Plus, it makes the time go by faster, I think, watching a video and actually crunching the numbers yourself and getting results yourself and learning. I think it makes watching a video that much more rewarding, that much more easy. It makes time go faster and all that. So like I said, we're going to start with a straightforward coin flip, and we're going to evolve. And my goal eventually is for you to be able to create EV tables for different situations using Excel Open Office and not a pen and paper or Microsoft Word and long equations with X's. So for the future of this series, which is very important, these are some of my ideas, and I'm not sold on all of them. I have just, since we came up with the idea for this series and I knew it was happening, I've just been thinking up ideas, and I just have, there's so many directions that it can go in. So I'm going to spell out some of them, and hopefully you all can provide some input in what you really would like to see. If you see a bullet point here or the next slide that you're like, wow, I need to see this, then please just let me know so I can make sure that it happens, because I have just almost too many ideas. So like I said, we want to understand poker fundamentals through our examples, so we're not going to get too abstract. I want you to become proficient in Excel Open Office Calc, and even better than just understanding poker math, just about any job you could have, I think, that uses a computer, it's important or a plus for you to know how to use Excel. So if you don't know how to use it, and let's say you're a student, I think that will help you a lot. It's just really, really useful. I use it for everything from making to-do lists, using it instead of a calculator, to running these types of tables. So I want you to know how to take a hand history, and it's not going to work for every single hand history, because a lot of them will just be very complicated. But I want you to be able to take a lot of these tough hand histories that you're posting on the Deuce Crack forums, and instead of having to post it, be able to run your own math, or when you post it, running your own math. I'm really interested in the what if analysis, and I think that's sort of one of the best parts about doing this in Excel is you can tweak different constraints to change the results, and you can see, well, if he had raised the turn, then such and such would have happened, or if he was under the gun instead of the button, the tighter range would have resulted in this being bad, and so on and so forth. So I think another thing that I'm pretty sure I'm going to do in this series is, all these buzzwords: game theory, balancing, merging ranges, polarizing. What's a polarized range? What does that really mean? And it's hard to really, read some definitions or read some posts and figure out what it really means. The best way to understand it is looking at the numbers, seeing how a hand really works, and seeing what this GTO strategy really means. And putting all this together, it's sort of the anatomy of a range. What does the breakdown of a range look like? So other fundamentals we'll explore. Implied and reverse implied odds. I already did a lot of research into that in Playbook, but I'll definitely kind of explain some of my findings and how that could apply to the overall EV equation. That's probably going to be in episode 2. What does it really mean to be at the top or the bottom of your range in terms of the best possible play? Value betting versus catching bluffs. That's something we're going to go into a bit either today or next week. Understanding multi-way pots and parlays. I think the parlay is something that a lot of people overlook. The parlay is basically, a simple example is you're on the flop and you have a hand that you're deciding whether or not to bluff with because you've got little to no equity. A parlay is that you need both players to fold. So, I'll break that down if that's something people are interested in. The math of bluffing and check raising, I'll do that because that's always fun, for me at least. Floating, slow playing in big pots versus small pots, very important. The example that comes to mind is, playing with like a half a pot sized bet behind, and why in that situation it can be okay to make some of those bets where nothing worse calls and nothing better folds. And then something else I think may be interesting and useful for a lot of you is take a look at win rates versus variance, and also stats by sample size, and how to figure out how much of a sample we need for these stats, and looking into that, because I think a lot of people put too much weight into small sample sizes, and I'll kind of if we do that, we'll explore when that's the case. So I really, 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 really need your input, because like I said, I have so many different directions I can go in, and I want to know what you want to see. And now my goals. My goals are for you to be able to do what I can do. So what certain situations would you like to see? Would you like me to take your hand histories and analyze them? Would you like to be on a video and I will kind of coach you in using OpenOffice to create or to model a hand history? Would you prefer us to break down ranges and do all the bar graph type things that I did in Professor Plotkin? What would you like to see? What would help you the most? So now we're going to start with today's work, which is going to be starting off in OpenOffice Calc. We're going to start with this very simple situation. Your friend offers you a flip. He'll give you $10 if it's tails. You're going to give him $9 if it's heads. What's the EV of the flip? And this is the type of thing, yes, we could do in just writing out an equation, do it on pen and paper. It's simple, but we're going to start with modeling the EV equation. And I'll be right back in OpenOffice, and we'll get started with our work. So here we have our OpenOffice Calc spreadsheet. Getting started with that, and so our first scenario, as I illustrated in the PowerPoint, was we have this coin flip where we are offered $10 for tails and we lose $9 for heads, and we will start developing and making some slight changes to our EV table, but this is going to be a very simple one. So follow along with me, please. For our cell A3, we'll type in results. For our next cell, we'll type in percent chance of the event, followed by net of the event, followed by our EV line. So we could leave it like this, but I am a big fan of formatting, making things look a little neater and nicer. So when we go back and look at this, say in a few weeks, if we wanted to refresh our memories on our results, we can come back and actually see what was going on instead of seeing a big mess of numbers. So if you highlight A through D of cell 3 like I have here, we can right click, we can go to Format Cells, and for the headers I like to have a little, this background tab here, I like to have a little gray background. I like to add a border in, so I'll use this 1.00 point border and just kind of draw a little square around it and a little line in the middle to make sure each box has its own border. And for the font, I want to have it nice and bolded so it stands out where our header is. So we have that, and I also like to center the headers. So up here we can center it, and here we have our header. So we'll fill it in. The results are the possible scenarios that could happen. For a coin flip, it's either heads or tails. We know it's a 50-50 proposition here, so 50% heads, 50% tails, and we also know the net of our event. If it's heads, we're going to lose $9. If it's tails, we're going to win $10. And now, what EV really is the sum of the products of each distinct event and probability, and the net of the event and the probability. So we multiply the percent chance of the event times the net of the event. And the beauty of Excel / OpenOffice Calc is that we can actually do these computations right in it, and it will do it for us. So we type in equals this 50% here times this $9. We don't even have to type in the numbers; it just will calculate it for us. Again, we can do equals, or we can start it off with a plus. I often start it off with a plus. It's a little bit quicker for me. This times this, and we add them together. And there are two different ways to add things. You can either just simply do one plus the other, or sometimes you're dealing with big lists and you want to add them all up without clicking each individual cell, and it's a little easier to use this equals sum function. And the sum function lets you do either highlight a block that it will add up. So if we did this, it would add all these up. If for whatever reason we wanted to do that, for what we really want to do here is add these up. Or alternatively, in Excel it's a comma. In OpenOffice it is a semicolon. We could type in this semicolon this, and if we wanted to add this one too, semicolon this. But for this, we'll just highlight and drag to cover that area. So our EV is 50 cents of our coin flip. Now, I'm going to tweak this a little bit to teach you what's called, or what I call, the final stack method. And the final stack method is a little bit unnecessary for a simple example like this. However, when we start going into these really complicated EV situations with different streets and different possibilities, it sometimes it becomes easy to lose sight of our frame of reference. So if I don't want to give an example because we're not even going to be bothering to use the other method, but from my experience, when I've helped people work through these things, the biggest mistake that they make is, well, I'll tell you, the two biggest mistakes that are made is, one, they try to do it using pen and paper or in Microsoft Word, coming up with these complicated formulas. It just doesn't work. Or two, they lose sight of their frame of reference, and I tell them, just do the final stack method. It is so much easier, and we're just going to do it that way. So what I mean by that is, let's copy and paste our header again. That's what's nice about keeping this header nice and neat. Just copy and paste it, very easy. So on top we'll write our starting stack. And we'll change this here to our final stack. So we're going to calculate the expected value of our final stack. This expected value is the expected value relative to where we started, which is the point of 0. But the problem with that 0 is it can be kind of arbitrary. Like, at what point are we really at 0? Once we start doing situations where we're looking at 2 street scenarios, or it goes bet, raise, and we 3-bet, and we want to know what happens when he 4-bets and things like that, it gets very complicated. So let's say our starting stack here is $100. We have $100 in our pocket with which we will use to coin flip, and we just want to know the expected value of each coin flip. Sorry. Whoa. Starting stack is all I wanted to add in. So still heads, tails, 50%, 50%. But this time, instead of the net relative to a starting point of 0, it's going to be the change in the final stack relative to our starting stack of 100. So we start with $100 and it comes up heads. We pay out $9. As a result, we're left with $91. Whoops. If it's tails, we start with $100. We win $10. So we have $110 in our pocket or our stack. Again, we just multiply one times the other. And now here I'm going to teach you another little Excel, open office calc trick. And that is when you have, see here we've multiplied B times C. And this next line, 13, we're still multiplying B times C. It's consistent. So what we can do is, instead of having to type in, and let's say we had 10 different possible results here, instead of having to type in this times this, this times this, this times this, you simply can copy paste this formula or drag it down using this little plus here in the lower right corner, and it does the exact same formula for us. So our net here is going to be our average final stack. We add them up using our sum function, and our EV is simply our average final stack minus our average starting stack. It's 50 cents, the same as it should have been. So we're going to use this going forward. Just to have our nice little neat formats. We'll use our borders here. Maybe we'll bold it. Actually, you know what? I don't want to bold it because I just want the EV to be bolded. So we'll give a little gray in there. Okay, so now let's say we're thinking about it, and we don't really know this person. He's offering us 9. He's offering us 10 for 9 on a coin flip. It seems a little weird. Maybe he's just a degenerate and needs that action, so he's giving us an edge in order to flip with him. Or maybe he's trying to cheat us. So let's decide that we're estimating that there's a 5% chance it's a trick coin. And by a trick coin, I mean it's always heads. So this is something that we're going to have to do from this point going forward. For most situations, when it's not so simple as just to fill it in 50-50, we're going to have to start calculating the percent chance in order to put in this event. And I talked about the 2 biggest mistakes that people often make. Well, number 3, when I was saying that people either do it on pen and paper or Microsoft Word, that's mistake number 1. Mistake number 2 is not using the final stack method. Mistake number 3 is trying to just plug in the percent chance of events, and they make errors that way. So we're going to try to keep it nice and consistent. So what does this 5% trick coin mean? It means 5% of the time, it's always heads. And that's going to transfer straight down. So we're going to underline that. Things that go to the table down here are going to be underlined. Things that don't are going to stay here. So the other 95% of the time, when it's not heads, it's fair. And when it's fair, of that, 50% of the time it'll be heads, 50% of the time it'll be tails. And in order to calculate that, we simply multiply the percent time that it's fair times the percent time given that it's fair that it is heads. So we'll change our format, press the percent button here, nice and neat and consistent. We underline that so we know to put it below. Now we multiply the percent chance that it's fair times the percent chance that it's heads, given that it's fair. Tails, I should say. Once again, we take our 0.475, turn it into a nice neat percent, highlight these, underline them, and now we've got exactly what goes below. This 5% heads and 45% heads can go below, and it's up to us whether or not we want to add these up or keep them separate. I will do both just to, for the sake of showing you different ways of doing the same thing. So there are 3 results: heads, heads, tails. The percent chance of heads number 1 is 5. And what we're going to start doing is tying these together. So instead of just writing 5%, we're actually just going to do equals this 5%. And what this lets us do is alter our percents here to run some different tests and change things around. And you'll see the value of that in a few minutes. So that's the equals 5%. This is the 47.5%. This is the 47.5%. Now, regardless if it's heads, we're going to end up, even if you cheated us, we're going to end up with that $91. If it's tails, we're going to end up with $110, which we already knew. So we multiply this together. Again, we can drag these down. We can sum them up. That is our average final stack. And our EV is our final stack minus our starting stack. I misclicked. So our EV is 0.25 or 2.5 cents. So now what we could have done, let's just get rid of this one. Instead of doing these separate heads lines, that's a little weird. So let's just delete that row, and now we'll add these together. So this is what it really should be, 52.5% heads, 47.5% tails. And given this, we should still take this bet because we have a net of 2.5 cents. Now, there are some other considerations that could come into play. Maybe we'll talk about those later in this series. Risk of ruin. Now, should we really be flipping, 10% of our bankroll for such a small expected value? Probably not. But that's beyond the scope of this particular video, but not necessarily beyond the scope of the series. So let's move on to another situation. Before we go into real, poker examples, I'll go into this one. We're going to play a raffle, and the raffle costs $10. And there are a couple of different scenarios that can happen. We can win prize A, we can win prize B, and I'm going to change what I have in my notes. We're going to add a prize C here as well, and then the other result is we lose. So let's say for prize A, we win our money back. Prize B, we win $25. Prize C, we win $100. And we lose. We obviously lose and get nothing in return. So prize A, we win 25% of the time. Prize B, we won 10% of the time. Prize C, we win 5% of the time. And if we lose, that happens the rest of the time. So what we know is these need to add up to 100%, since these are the only 4 scenarios that can happen. So we can simply start with our 100 and start subtracting this, and perhaps you could have done it in your head, but that gives us this net result of 60%. We'll use our starting stack method. And this time we've started with $10. This raffle is our last $10 in our pockets. So now what we can do is just copy and paste these down. And once again, like I said, we want to tie these in. So we want to do equals prize A, equals prize B, equals prize C, equals lose. Our final stack, the amount of money in our pockets, we pay the $10 to play, and these are our returns. So $10 is effectively getting our money back. Prize B is winning 25, prize C $100, and finally, if we lose, we get nothing. We multiply these together. We drag down. We sum. Whoops. And this is our final stack. And our EV for this one is going to be 0. I did not mean for it to work out that way. It just kind of did. So let's say the people of the raffle, they change their mind. They don't like how it's working out, so they decide to change it. So now prize A, you only win 20% of the time, and everything else stays the same except for the chances of losing. So now our EV is minus 50 cents. And this is really the nice thing about Excel, and specifically about tying in the percents to the results over here, is that we can keep changing these around and seeing our net results. So for poker, this may be similar to changing our opponent's bet size, to changing the size of the pot, to changing our our equity, our fold equity. So you can quickly change these things, and it instantly gives you the resulting change. So let's say prize A happens now 50% of the time, but now there's no prize C anymore. Now our EV is losing $1.60. Let's say, whoops, I did 59%. So yeah, I mean, you could play around with that and see the resulting expected values of those situations. So we're going to move on to like a simple poker river game. Now first we have a deck of 13 cards, all spades. So 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace of Spades, one of each rank. And we're going to take the simple river game. Hero is in position, or river / one street poker game. Hero's in position. Villain checks 100% of his range. Villain check calls 10, Jack, Queen, King, and Ace. Else check folds. So if he's got a 9, he check folds. If he's got a deuce, he check folds. So the pot is $10. Stacks $10. Bet $10 or check. Only options. So my question is, should Hero bet with a 2, a 9, a queen? And this will be the last example that we will do for today. And I will leave you off with a quiz question, which will be my goal for most, if not all of these videos, will be to leave you off with a little bit of a quiz question to challenge you to think a little bit further about these. So this is going to bring up a common concept in dealing with poker math, and that is comparing the EV of one play to another play. Now, people often think that all they need to prove is that a certain play has a positive expectation. But as all poker players should know, you don't want to know if one play is a positive expectation play. You want to know if one play is the best possible play you can make. Now, if you're in a situation where, let's say in this scenario, our opponent went all in instead of checking, and our decisions are between folding and calling, then the EV of folding is 0. That's a truism. The EV of folding is always 0. So we just need to figure out if the expected value of calling is greater than 0. So we wouldn't even need to calculate the expected value of folding. That's the scenario where you only need to look and only need to calculate the expected value of one thing, one result. Here we need to figure out the EV of betting, and we need to figure out the EV of checking. There is expected value of checking. For example, if we were to check down with the ace for whatever reason, we're always going to win. We're always going to win $10. So the EV of checking with an ace is actually $10. So we would need to prove that the EV of betting is greater than the EV of checking, which it clearly would be because betting the nuts is good. That I'm just explaining to you why we're going to actually have to calculate two EV tables. So here, first we're going to say that Hero has the deuce, because that's our first question, and we're going to figure out our betting constraints. So we're going to make a little table figuring out the percents, the results, the number of cards, and the percent chance of each thing happening. So first, just to I don't know, just make it a little bit easier, I think we'll just write down that 100% of his range is all possible cards is 12 cards. We have the deuce. He can't have the deuce, but he can have any of the excuse me, he can have any of the 12 other cards. So there are three real results. He can fold, he can call with worse, or he can call with better. And actually, I find it's a little bit easier if we write it from our perspective. So he calls. If he calls with worse, hero wins. If he calls with better, hero loses. So we'll write it that way. And now what we can do is, see, this doesn't really fit. We can stretch our column out a little bit. So which cards does he fold? We can simply count on our fingers. He folds a 3, 4, 5, 6, 7, 8, and 9. So he folds 7 cards. We have the nut low, so when he calls, we're never winning. And he calls and we lose with the jack, 10, jack, queen, king, ace, and that's 5. And we'll calculate our percents. 7 divided by the 12, 0 divided by the 12, and 5 divided by the 12. Make our nice, neat percents. And again, we'll underline these percents here because these are the numbers that will translate to below. Let's copy and paste our headers again. This time we're starting with $10 in our starting stack, and we can just simply copy and paste these results. They are the same as below. Again, we'll tie these in. He folds 58.33%. He calls with worse, 0%. He calls with better, 41.67%. So we've started with $10. There's $10 in the pot, and our opponent has $10. When our opponent folds, we started with our 10, we get that back, and we win the 10 in the pot. So we have 20. When our opponent calls and we win, now we get the $10 in the pot, and we get his $10 on top of our original $10. So we have $30. When we go all in and he loses, clearly we're broke. So same as before with this calculation. And that's our average final stack. And our EV is our final stack minus our starting stack. And our EV is $1.67. And that's our EV of betting. You could put it here, you can put it here. Just make sure you realize that that's your EV of betting. So now let's move on to, hero still has a 2, but now you want checking constraints. Same as before, results, number of cards, percent chance. I could have copied and pasted. Again, all cards, typing fail, 12 cards, 100% of his range. That's simple. So there are two things that can happen when we check. We can check and we can win, or we can check and we can lose. Clearly with the deuce, we have the nut low, so when we check, we're never winning. Like I said before, with the ace, when we check, we're always winning. So the EV of checking with an ace is, you get the full $10. The EV of checking with the deuce is clearly going to be $0. For the sake of completeness, sake of consistency, we'll divide here, even though we already know that it's going to be 0% and 100%. And we'll copy our same EV table over. Control C, Control V. Results are win or lose. We could have copy pasted, but we didn't. Still want to tag or tie in our 0% and our 100%. And as I said before, when we check, we can either win or we could lose. When we win, we end up with $10 more than we started with, $20. When we lose, we end up with exactly what we started with. We haven't bet, so it doesn't cost us anything. We change it to the EV of checking. We multiply. We bring it on down. We sum them up. Our average final stack is $10. Our EV is our final stack minus our starting stack. So as we expected, our EV of checking is 0. So what we've seen here is that the EV of betting is greater than the EV of checking. And if we want to even make it a little more clear in front of our eyes, which is which, we can do it that way. So in poker concepts, what does this really mean? Or what does this illustrate? This illustrates what happens when you have the bottom of your range. When you have the bottom of your range, the EV of checking is, the EV of checking is going to be 0. You have no chance of winning at showdown. And that's why it's often correct to bluff with the bottom of your range, because you have there's no way of winning otherwise. You have 0 showdown value. As a result, the EV of betting just has to be greater than 0, since you have no chance of winning. So, this illustrates, what happens when you're at the bottom of your range. It's just a matter of, does your opponent fold often enough? Now, going one step further, if we're bluffing here, and we only have to make a positive expectation bluff, since we know checking has 0 EV, we're betting 10 to win 10. So it's a 1-to-1 ratio, and it has to work 50% of the time. It's like a coin flip. So the reason why this is a positive expectation play is because out of the 12 cards he can have, he folds 7 and he calls with 5. If for whatever reason he decides to call with a 9, it'll come out to 0 EV. But that's not the case because he folds a 9, and as a result, betting is the better play. So something that I've done throughout my math videos is to keep a log of my results. It's really nice because you can take a look afterwards and see what your actual range will look like. So we'll start with card, EV of a bet, EV of a check, and best line. So here's another little Excel open office trick. If you highlight 2 numbers in sequence, or like January, February, like 2 numbers in sequence, you can drag them down and it'll fill it in for you. So we'll go up to a 9, we'll write out a 10. Move them over to the right for consistency. Shrink it down to make it look nice and neat. So the EV of betting is 167, the EV of checking is 0, and our best line is bet. Now, what happens if this 167 is not really 167, which it's not? It's 1.6667, and it keeps going. It's 1 2/3, and as a result, this is what happens. So, what we can do is what's called paste special. So right-click here and copy. Right-click here and paste special. And yours is gonna look something like this, where the paste all is checked in. You want to uncheck that, and now uncheck everything. And what these different ones tell you is, for example, if I copied in the format, then it'll put in the the dollars and cents here like this. So we'll do that just to show you how it works. So there you go, and it's bolded just like it was here. So it copies in the exact format. If we copied in this format and pasted it here, we'd get the gray background and the border, but we don't want that. So let's copy again and do another paste special. Copy, paste special. Now instead of formats, let's do numbers. And that's going to paste in the exact same number that this is. Instead of doing 1.67, let's hit OK. It's 1.66666667. So we get the exact same number as is here. So that's why that's useful. And for the sake of consistency, we'll do the same thing here, even though we know this is really 0. So copy, paste special, make sure we got the number, and there we go. And just to keep our formats consistent, let's change these all to dollars. So when we paste special in, we're good. So let's change it to a 9. Now, whereas the 2 was the bottom of our range, the 9 represents another interesting point of a range. This is the point where all better hands call, all worse hands fold. So, based on what we know about poker, this should be a disaster to bet because we can check and all the cards that'll fold, we're just going to beat them anyway. So there's no point in bluffing. And when we bet, we're only getting called by better hands. So what's interesting is that the value of betting is the same as betting with the deuce, as it will be the same as betting with a 9, an 8, a 7, a 6, a 5, a 4, or a 3. So there are 12 cards. He's going to fold with 7 of them. He's going to call only better hands, that's 5 of them. So it's just going to be exactly the same. The difference is, when we check it down, we're going to win when he has a 2, a 3, a 4, a 5, a 6, a 7, or an 8. That's 7 cards. And we check and we're going to lose when he's got a 10, a jack, a queen, a king, or an ace, but he's going to call with those anyway. So now the EV of a bet is still $1.67, but the EV of checking is huge. We have a lot of showdown value. And this, further illustrates why we're betting with the bottom of our range and checking with, this hand here. So we'll do our copy and paste special. And as we have determined, we should be checking here. And now let's move on to our queen. Now when we have a queen, it's different. Instead of 7 folds, we're actually getting 8 folds because we no longer have one of the cards that fold. So we can again count on our fingers, 2, 3, 4, 5, 6, 7, 8, 9, all folds. That's 8 cards. Now, instead of 0, worse hands calling, we're actually getting some value here. When he calls with a jack or a 10, we win. So we got value on 2 cards, and we value cut ourselves if he's got an ace or a king. So we bet and lose on 2 cards. So now the EV of betting is significant because there is value, and that's why it's much greater. Now if we delete these numbers as well, when we check and don't value bet our queen, we win on 10 cards, 2 up through jack, and the only times that we lose are when we check it down and he flips over an ace or a king. And now what we'll notice is that these numbers are the same. So it's actually, we'll do our paste special. It's actually neutral. We are indifferent between betting and checking with the queen. And now what this represents is a hand right in the middle of our opponent's calling range. Since a value bet, by definition, needs to work 50% of the time, in other words, it needs half the time we need worse hands to call. And in this situation, half the time we got to call, worse hands call, 2 out of 4. By definition, it's a break-even value bet. So we're neutral here as to whether or not we should be betting. Now, something that we can get into for next week's video is understanding what our range looks like, doing things like betting with the queen even though it's neutral because it may put our opponent in a more difficult situation, and that sort of lets us shape our own range. So next week we'll fill in this table and we'll see what our range looks like. As a little spoiler, it's going to be a polarized range. That is, all these cards in the middle are going to be cards that we should be checking, and we should be betting them both the top and the bottom of our range. So we'll talk about the ramifications of that as far as how our opponent may respond and how we can respond as a result. And we'll go into some more of these tables. We'll go a little bit deeper into them. We'll go into what happens if our opponent decides that he's going to check raise an ace, a king, or maybe a deuce as well. What happens when our opponent decides, what happens if we're out of position instead of in position and we no longer have this situation where our opponent is checking his whole range and we know exactly how he's playing. It becomes a little more difficult when we're out of position. So we'll get a little bit further and deeper into creating our EV tables, and hopefully through that you'll get a little more comfortable creating these EV tables and doing them on your own. and we'll get some better ideas of understanding sort of the inner workings of poker, especially on the river, because once again today we got to see what happens when we're in the bottom of our range, what happens when we're at the point where all better hands call and all worse hands fold, and what happens when we're at this point where we're right in the middle of our opponent's calling range as far as us value betting. So I'm going to leave you off with a quiz, and I'm going to try to do that for as many of these videos as possible, as many for that are appropriate. So my question here is, what is the best card hero should bluff? So clearly, if we have a jack, a queen, a king, or an ace, worse hands call. So we're not bluffing, we're value betting. So I want to know what's the best card of two up through 10 that hero should be bluffing. So I will start next week's video off with, as I said, completing this table and figuring out what the best, the best card that we should be bluffing is. And, I absolutely, in the future, I'll probably have you guys post in the video thread your answers. But I think for this one, I'd prefer if you didn't post your answers. But if you have any questions regarding doing this, absolutely, I'm happy to answer. And as I mentioned before, I would really love it if you guys posted and let me know exactly what you'd like to see, because that's really important to me for the rest of this series and making it as valuable for you as possible. So this will wrap up this video, and we'll continue with this. So if you'd like, you can go ahead and save it. And this has been Josh for Deuces Cracked, and thanks everyone for watching and typing along with me here.